of section 2.1. Next section is interpretation of derivatives, but I introduced the derivative together with this interpretation, so I think it's just going to be a review. So I will just mention, and once again, the meaning of this derivative, right? Derivative is a term for function itself, but when we're looking at function representing the position of motion, and its derivative becomes velocity, right? Instantaneous velocity. So I got this cool animation. I'm going to share the code with you. So the whole thing, this is a motion, and this, if you download this one in your Mathematica and if you play it, and it shows that actual motion up and down, this actual motion is that red dot, and this is the Newtonian spacetime. This is the time coordinate, and this is the value right above it, right? So this is a motion, and what it represents at that stage, for example, all right, it is showing the time as well, so it's a motion. That's actual motion going up and down, and this seems like t equals 1.75 second or something like that, right? At t equals 1.75 second, what is the position? Seems like almost negative 2.5 below the 0 point, right? So that's what it says. But how fast do you think it's moving? Can you kind of guesstimate? How would you do that? If it is moving up and down by looking at it in here, just looking at that position, you have absolutely no clue how fast this was moving, right? You only know the position is roughly the position S they use, negative 2.5. Fair enough? But how fast, by looking at it here, how fast is it moving? No idea. But if you look at it here, right? What is the velocity in the graph? What is the meaning of the Newtonian spacetime? The slope, right? The slope tells you what the speed is. So here you draw a tangent line like that, and you try to estimate slope of this line by go on, rise over run. You go walk this many units and that many units. That tells you the slope of this line, right? Because it's not perfect scale. You can see this is 1 unit. This is negative 2 units. It is not in correct scale. So you have to really walk, all right, to this 2 units, to this 8 unit, although you actually move a lot smaller units there. So if you measure that, you have a good guesstimate about how fast this one is moving, because the slope of the tangent line is the velocity, right? We're mixing it together now. Does that make sense? Yeah. So whatever that is, whatever that slope is, you can measure that. So definitely this MC there, 1.75, that is a velocity, 1.75, right? Do you see that? That's a negative number, right? It's a negative slope. So that means you're going downwards. At that stage, you was moving down. If you were here, slope is like this. It's a positive slope. Therefore, even though it is at the 0 point in here, it was moving up and things like that. Fair enough? What would you say about slope at that point? Slope of this thing. 0, right? Slope of the tangent line seems like a 0. So 0, MC here is a 0. That means velocity is a 0, right? Can you describe this motion? What is happening around that time? It's not moving, but not at that moment. Around it, around that point, what kind of motion is it? Yeah, I call this the yellow light motion. It's a yellow light. You're slowing down, almost stop. What the heck? You just go still, keeping forward. That's that motion in here. So I'm going to show you that motion at that stage. Pay attention when it hits here. It stops and continue going forward, right? So if you look at it like that, that's that kind of motion. If you look at it like that at the top here, that's slope still 0, right? But it changed the direction. We're going to see it in here. When it approaches there, it move up and change the direction and come back up. And that's the moment you stop and become 0 and change the direction. But in here, you stop, but don't change the direction. Just keep going forward in here, right? So by looking at this Newtonian motion in Newtonian spacetime, you can tell a whole lot about the motion by looking at this graph in here, right? So you don't need this animation. You look at this static picture, you can reproduce motion in many ways. Fair enough? So if you have downloaded Mathematica, you can download this thing and play yourself. Okay, so that's the interpretation here. Motion and velocity, and one more, right? Acceleration, if you know physics, and that's what we're gonna enter eventually. But we just look at the graph in the space-time, made a connection to the slope of the tangent line and velocity, and they're all tied together. All right? Fair enough? Yeah. That's all I have about that section. Just review the meaning.